Hello everyone, good morning. Our lesson today talking about angles, measures and segments length. At the first, let me identify what does it mean by secant. Secant is a line that intersects the circle in 2 points, like the secant here. As you see, the secant AB intersect our circle in 2 points. The angle measures here, how to find the measure of an angle formed by the intersection of two lines inside and outside the circle. Here we have the first theorem, theorem 1213. The measure of an angle formed by two lines that intersect inside the circle equal half the sum of measures of the intersected arcs. That means here if we looked at this angle, angle 1, this formed by the intersection of two lines inside this circle. The measure of this angle, angle 1 here, this equal half the sum of measures of the intercepted arcs. That means measure of angle 1 equal half the sum of the measure of the two arcs, arc X and arc Y. What about if the intersection of the two lines here outside this circle? Maybe you can find in this case here we have two secants intersecting our the intersection of them outside this circle, or the two lines, one of them tangent and the other is secant, or both of them tangent. The same idea. The intersection of two lines, if it was outside this circle, then the angle, like angle 1, the angle that formed by the intersection of these two lines here equal half the difference of the two intercepted arc. That means measure of angle 1 equal half the difference of measure arc X minus arc Y. Then we have two theorems about the intersection of the two lines. The first theorem, the angle that created or formed by two lines intersecting inside this circle equal half the sum of the two intercepted arc, like angle 1 here. This one, the first theorem, equal half the sum of the intercepted arc, arc X plus arc Y. But here if the intersection was outside this circle, then the angle that formed by this intersection of the two lines equal half the difference of the intercepted arc. That means angle 1 here equal half the difference of the two arcs, arc X and arc Y. Let's apply the two theorems by solving these two questions. By solving the first one, here according to the given, look at angle X. Angle X here formed by the intersection of the two secants or the two lines here. Then measure of angle X here equal half the sum of measure of the two intercepted arc. That means measure of angle X equal half the sum of 46 plus 90. Then measure of angle X equal half this sum, 46 plus 90 equal 136. Then half 136 equal 68. By looking at the other question here, how to find the measure of this arc, arc Z, according to this intersection was outside our circle, whatever, if this line, one of them tangent or both of them tangents or both of them secants, it doesn't matter. The same idea, we will apply our theorem. Then measure of angle 20, this one equal half the difference, as we said, half the difference of the two intercepted arc, arc 95 and arc Z. Here then by multiplying both sides by 2, then 40 equal 95 minus Z. By solving this equation we will get that Z, the measure of this arc, equal 95 minus 40, then Z equal 55. Let's solve another example. What is the value of each variable? Like variable W. Here we have angle formed by intersection of two lines outside this circle. By applying the same idea, then this angle equal half the difference of the two intercepted arcs. That means 70. equal half the difference of the intercepted arc W, and arc 110. Then by solving this equation, we will multiply by 2 for both sides. Then 140 equal W minus 110. Then by solving this equation, we will get that W equal 250. By looking at the next one, how to find the measure of angle Y. This is the same idea. An angle formed by the intersection of the two seconds. Then here measure of angle Y equal half the difference like the first question. Then measure of angle Y equal half the difference of 110 and 30. Then measure of angle Y equal 40. How to find the measure of this arc X? Here we have 2 seconds intersecting inside this circle. Then measure of angle 35 supposed to equal half the sum, yes, half the sum of the two intercepted arc X and arc 30. Then 35 equal half X plus 30. Then by multiplying by 2 both sides, then 70 equal X plus 30. Then X equal 40. Here, by looking at this problem, a satellite in geostationary orbit above Earth's equator has a viewing angle of Earth formed by the two tangents to the equator. The viewing angle is about 17.5. What is the measure of the arc of Earth that viewed from the satellite? This arc AB. By applying our theorem, we know that measure of angle 17.5 supposed to equal half the difference of the two intercepted arcs, arc AB and arc AEB, this arc. Let me represent this arc AB using the variable x. Then measure of the arc AEB supposed to equal 360 minus x. Okay, by applying our theorem, this angle 17.5 equal half the difference of the two arcs. By making a substitution here, then 17.5 equal half their difference. Then by combining the likes, negative x and negative x, then we have negative 2x. Then 17.5 equal half 360 minus 2x. By multiplying both sides by 2, we will get 35 equal 360 minus 2x. By solving this equation, we will get that 2x equal 325, then x equal 162.5. The segment length. How to find the segment length? By applying this theorem, let me explain the theorem. For a given point and circle, the product of the length of two segments from the point to the circle is constant along any line through the point and circle. Let me explain that by using another words. If we have two chords intersecting inside the circle or outside the circle, seconds, both of them or one of them tangent and the other is secant, let me explain the first case. Here, if we found the two chords intersecting inside this circle, then the segments, the product of the segment of this chord, like this part AB times A times B, these two segments equal the product of the other two segments, C times D. The second case, if we found two seconds intersecting, then intersecting outside the circle, then the outer segment times the whole second, the outer segment W times the whole secant W plus X equal the outer segment Y times the whole secant Y plus Z. The third case here, if we found the intersection between the secant and tangent, it was outside the circle, then the outer segment Y times the whole secant Y plus Z equal the square of this tangent t. That means the first case, if we found the two chords intersecting inside this circle, then the product of the chord segments are equal. That means A, this segment, times B equals C times D. The second case, here the product of the seconds, the two seconds here, as we see, the product of the seconds and their outer segments are equal. That means the outer segment W times the whole secant W plus X equal the outer segment Y times the whole secant Y plus Z. The third case, if we found here intersection also outside the circle, outside the circle, then the product of the outer segment Y times the whole secant Y plus Z equal the square of the tangent. That means T squared equal Y times the whole secant Y plus Z. Let's apply the three cases. By solving these two questions, find the value of the variable. According to our theorems, we said if we found the two seconds intersecting outside this circle, then the product of their segment and the whole secant are equal. That means 6, the outer segment, times the whole secant, 6 plus 8, equal 7, the outer segment, times the whole secant, 7 plus y. This both of them equal. Let's solve this equation. 6 times the sum 14, this equal 84. 7 using the distributive property, 7 times 7, 7 times y. Then 84 equal 49 plus 7y. By solving this equation, we will get that 7y equal 35, then y equal 5. In the other question here, we have secant and tangent intersecting outside this circle. Then according to our theorem, we will apply that the outer segment 8 times the whole secant 8 plus 16 equal the square of the tangent z. Then z squared equal 8, the outer segment, times the whole secant 8 plus 16. By solving this by distributive property, then z squared equal 192, then z equal 13.9. Let's solve the other question. What is the value of the variable to the nearest tenth? By the same idea, we have two seconds intersecting outside this circle. Then the product of their outer segment and the secant are equal. That means 14, this is outer segment, times the whole secant, 14 times 20. This equal 16, the outer segment, times the whole secant, 16 plus x. By using a distributive property, 14 times all the sum 14 plus 20, this equal 476, the same as this one, 16 times 16, 16 times x. Then we have an equation, 476 equal 256 plus 16x. By solving this equation, we will get that 16x equal to 120. By using a division operation, we will get that x equal 13.8. By solving the other question here, we have two chords intersecting inside the circle. Then the product of the segment of each secant are equal. That means 3, the segment, times 7 equal 6.5 times 3. 6.5 times m. Then by solving that, here 6.5 m equal 21, then m equal 3.2. Thank you for listening and have a nice day.